Okay, okay. I think a lot of people are here. I think we could give it a start. Okay. So, to introduce our next speaker, he is a senior security researcher at Pentera, specializing in securing Kubernetes, containerized environments, and cloud infrastructure. His work focuses on vulnerability research and emerging attack vectors, integrating these insights into Pentera's automated security validation platform. Before joining, he led a security research team at CyberArk. So without further ado, let's welcome Mr. Nir Chaco.
Hello, everyone, and thank you for joining today's session. Two devices walk into Azure, one's a Phish. Now, for today, I have one main goal. I will try to do my best so that by the end of this session, you won't only understand how attackers abuse Azure OAuth Flow for phishing attacks, but you will also be able to perform the exact attack chain by yourselves, hands-on, and be able to defend against it. As you probably realized, we're going to talk a lot about Azure today, but before we do that, I want to talk about Netflix. If you ever tried to connect your smart TV to Netflix, you've probably seen this on screen. On the one hand, you have the URL or the QR code that will get you this URL, and on the other hand, you have this code that you need to insert into. And you probably ask yourself at this point, why the hell are we talking about Netflix right now? And I would say that that's a great question, and you will get your answer in about 10 slides. Okay? Oh, yeah. I understand that they are looking for a bit more people to join us because they got mixed up with the time. So if you're here, thank you for coming on time. You'll hear it once again afterwards.
Okay, so since we are a bit early, we have some time. Could we bring some people from our sponsor side to please come on the hall? Okay? Okay. So, I'm just gonna, as usual, I'm gonna go around the room. I'm gonna call for some people from the other side of the room, and then we'll bring them here. Oh, si ano, lagi to dito. Kumusta pare? How are you?
Hello po, okay lang naman po.
Good. Sino kasama mo? Nasa ano, kabila. Tawagin mo yung mga friends mo, punta tayo dito sa harap. Teka, magtawag ako sa kabila, and we'll bring them here. And thank you guys for, being in the hall on time. And for guys on the vendor area, no, all our vendors will be there till tomorrow. They'll be there until tomorrow, so, there's more time to go back. And you could always drop by the main hall. Guys, you want to drop by the main hall? Come on. Okay, let's give it some time for the others to come back. Okay. Hi, Alex. How are you? Okay, come on, guys. Let's go to the main hall. And let's very exciting talk from our friends from Pintera. 10, 10. Okay, I'm seeing a lot more people. I'm seeing a lot more people. Anyone here from Hong Kong? Anyone here from Hong Kong? No friends from Hong Kong? Okay, yeah, they had some, there's a storm in Hong Kong right now. So it's unfortunate, but I was just curious if you have friends from Hong Kong. How about from Singapore? And there you go. Hello, hello. So we have friends from Singapore. And so I do hear that we have a lot of more people from all over Asia coming over the Philippines. Anyone from Malaysia? Anyone from Malaysia? No? Anyone from Taiwan? No friends from Taiwan yet. From Thailand? There you go. I know this. There you go. Hey, hello, hello, hello. See? Doesn't look like Thai, but I'll accept. I'll take that. Okay, so I think we're right on time. I think we go ahead and start. And again, to talk about two devices walk into Azure, one's a Phish. We have our next speaker, Sir Nick. let's give him a round of applause.
Okay, let's go again. Thank you for the ones of you who are going to hear this one more time. And welcome to all of you new joiners. So today we have the session of two devices walk into Azure, one's a Phish. My main goal for today is to do my best so that by the end of the session, you will not only understand how attackers abuse OAuth flow in Azure for phishing attacks, but you will also be able to perform this attack chain by yourselves, hands-on, and be able to defend against it. As you probably realized, we're going to talk a lot about Azure today, but we will start off with speaking about Netflix. If you ever tried to connect your smart TV to Netflix, you've probably seen this on screen. On the one hand, you have the URL or the QR code to scan that will lead you to this URL, and you have this code to put inside. And if you ask yourself, why the hell are we talking about Netflix right now in this session? I would say that that's a great question. Thank you. You will receive the answer in about 10 slides. Hey, my name is Nir Chako. I'm an electrical engineer. I've been cybering for more than a decade now, and I'm a senior security researcher at Pantera. I'm also a huge Harry Potter fan, so if you want to talk about this later on, you're welcome to catch me at our booth. Today, we're going to cover the OAuth 2.0 magic, and we're going to look specifically on Entra ID tokens. Then we're going to deep dive into device authentication flow, hashtag Netflix. We're going to teach a man how to phish, and we're going to cover some post-exploitation steps, including the remediation part and some time for Q&A by the end of this session. So if you have any questions, write them down. I'll be more than happy to answer them. The simple OAuth 2.0 version, the reason that I'm stating it's the simple one is that there are a lot of variations to it, but we will cover the simple one. It will be more than enough for today. What we have here is we have Bob, and Bob wants to use Microsoft Teams. In order to do that, Microsoft Teams will ask Bob for its credentials, and Bob will give it right back. Now Microsoft Teams, the application, which is the client, would like to understand what can Bob do. In order to do that, it will interact with the authorization server, Entra ID in our case. It will give it its full credentials and will receive right back the access token and refresh token. These tokens are inside of a specific scope of permissions with the answer of what Bob can actually do. Then the application can use this access token with the resource server itself, in our case, Microsoft Graph API, to perform all sorts of stuff. For example, if Bob wants to send a message to Alice, the application will use the access token, will ask the API to send this message to Alice, and that's how it works. So that's the simple version of OAuth 2.0. What I love to do is to understand how things actually work. So behind scenes, what you have is this HTTP post request. This is how Microsoft Teams interacts with the authorization server, with Entra ID, to get the access token and refresh token. So what you have here is the scope of permission, starting with graph.microsoft.com, the default permissions, and the offline access flag to get the refresh token. Then you have the client ID, which represents Teams application, and the credentials themselves. You have the grant type as password, and the username and password. As a response, you will get this. But what does it all mean? So let's start from the top. Here, you have the scope, which is the permissions granted for these users directly through the client. So what you can see, for example, is that Bob can access the user read basic all call, which means that he can enumerate and read the basic data of all of the users in the tenant. An important thing to know about this scope is that it defines the maximum potential, meaning that he can potentially access this, but if you have some sort of a conditional access defined in Azure, he might not be able to. That's something that it's so important to remember. Other than that, of course, you will have the access token itself. The access token itself. That's the short-lived credentials, and that's how the client interacts with the users, with the resource server. It's a JWT token, which means that you can decode it and see what's inside. So you have in the audience the graph.microsoft.com. You will have the app display name in a human-readable way. So now it's not just the ID. You can see it's Microsoft Teams, the name of the user or the service principal, and just the scope once again. So we came here to speak a little bit about phishing. So let's get these creds. In order to do that, you would first need to perform a phishing campaign against Bob. So you would need to have some sort of a credible domain name like Microsoft AzurePortal.com. You can buy it online, by the way, in GoDaddy. Then you would have to have the backend service to collect all of the harvested credentials and more phishing shenanigans stuff, making sure the website looks exactly the same, that the buttons actually work, that you use an SSL certificate, and on and on and on. And it's not only that. Now that you have a new website, the browser won't remember your credentials. So from the victim's perspective, he would need to put its full credentials once again. Speaking of it from the social engineering aspect, it's just one barrier that you need to cross. And not only that, you need to deal with MFA, FIDO2, Windows Hello, whatever you have on the way to make sure that this thing will actually work. I'm a hacker. Hackers are lazy, maybe you are too. And I don't like to work so much for something that might work. What I want to do is to put as little effort as I can to gain as much as possible. So what can we do? This is where it all connects. What you see here is a thing that is called the Device Authorization Grant. It's part of the OAuth 2.0 magic, let's say. And what happens here is that one device authorized another device to log in. So in our example, you have the smart TV as the device client interacting with Netflix authorization servers to receive this URL and user code, and then display it to you just like this. On the user side, you would probably use its smartphone to access this, right? And you will put the user code right inside there. So now the authorization server will know that this already authenticated device actually authorized the other device in. Then the other device in the background will start to poll and ask again and again, did the user authorize me yet? Did he authorize me yet? And once the user did, this television will get the access token and refresh token. And it's exactly the same in Azure. What you see here on screen, you have the Azure logging command as part of Cloud Shell inside of Microsoft Azure environment. Exactly the same flow with the URL and the code to put inside. What it means is that it's not some sort of an edge case in Azure, but it's part of the building blocks of authentication in this environment. But why am I speaking about it, and why do I think it's a better phishing tactic? So let's have a look. What you see here is that we changed the subject a little bit, and now we have the attacker's device as the client device. The attacker will send Entra ID the request for a URL and user code. He will do it just like that, with the device code API call. And as you might see, there's nothing about a scope, a user, nothing like that. All you have is the scope of permissions that you want and client ID. No tenant, nothing, which means that it will work with anyone who would go inside there. Now the attacker will take this response with the user code and verification URI, which is a valid and legitimate Microsoft domain URL, and send it in a phishing email to its victim. The victim, on the other hand, will see a legitimate link. It's microsoftonline.com, OAuth 2, and device authentication. Anyone that would look at it will see it's a legitimate Microsoft domain. So from the victim's perspective, what will happen is that if the video would work, yeah, it will put the code inside there, and then because it's a legitimate Microsoft domain, the browser will remember its credentials, no barriers here, and it's a Microsoft Teams application. It's a first-party application by Microsoft that you should trust. On the attacker's plan, he can now start to poll again and again, just like the smart TV from before, and ask, did the victim authorize me yet? And once he did, the attacker will get the full set of access token and refresh token. It would look something like this. So starting from building the full request, the attacker can use, for example, our tools, I will show it by the end of this session, to get the first details. So you will get the verification URI and the user code just like this. Starting, works a little bit slow today. We'll give it a second. Okay. See, it's a bit slow today. Let me open it from my own computer. 1 second, locally. Okie dokie. Nice, okay. So what you see here is that we have our tool. It will use the verification, URI, and code, but before that, the attacker needs to choose its client. For example, Microsoft Teams. Then it will get the verification URI and the user code, will send it as part of its phishing campaign, and then just wait and attempt to poll again and again for these credentials until the victim will let him in, and then the attacker will get the full access token and refresh token right to its hands. And you know what? At this point, it's a great point for the attacker to be in. At this point, the attacker can not only get a hold of this access token, he can actually use it. So as we talked about before, he can enumerate the entire users in this tenant. But sometimes, it's not all fun and games, and you get this error, which none of us likes, right? So it's the token is expired error. And at this point, what you can do is go to the last part of the puzzle, the refresh token. And as the name suggests, it helps you to refresh and get a new set of access token and refresh tokens. So what you can do is to perform this API call, to refresh the token, and the only thing that you need to do, you keep the scope and client ID just the same, but you change the grant type to refresh token and put the refresh token right inside there. That's a great success for the attacker, and he gets an access for at least 90 days from this point onwards, allowing him to refresh again and again and get a new set of access token and refresh token until someone will know that something happened. But as attackers, we don't think only about our closest goal. We need to think about what else can we get. And to answer the question, which road should I take, just like in Alice in Wonderland, we need to ask, where do you want to go? This question, where do you want to go, depends on the permissions that you will have, the part of the scope of the permissions. And the scope of the permissions that you get is in part of this access token, it's defined by the combination of the scope and client IDs. Meaning that if in this request, interesting, if in this request we will change, let's say, just the scope or just the client, we will get a different set of permissions. So if we will take, for example, instead of Microsoft Teams, we will change it to Microsoft Azure CLI, you will get a different set of permissions. If we saw before with Microsoft Teams, you will get all of this. Part of them can be user read basic all, files read write all, mail read write, and mail send. And each one of them actually represents something that the attacker can do in his attack chain. He can enumerate all of the user, can access all sorts of files in OneDrive and SharePoint, and then he can use the mail permissions to create a phishing campaign from within the organization. But what happens if we hit a dead end? We got this scope of permissions, but maybe we're not allowed to do it because of conditional access. Maybe we tried and tried, but nothing really helps us to propagate the attack. What can you do? I want to take you back in time 8 slides ago when we looked at the refresh token. We looked at this and we talked about it being self-explanatory. It helps you to refresh your tokens. But what the fucky is that? What you have here is the fucky equals 1. And in computer language, it means that fucky is true. Fucky is the family of client IDs. It's something that is specific for Azure. It's not like an OAuth 2.0 stuff. It's specifically for Azure. And they created something that is called an FRT, Family Refresh Token. It means that if you have a client as part of a family, it can use the refresh token to get an access token for another client in the same family. It's an undocumented behavior of Azure or Entra ID, but it's definitely observed. Meaning that if we will take this family, this is part of the family, by the way, it's not the whole family, but you have Microsoft Teams, Azure CLI, you have Office Desktop and Visual Studio, you can change the client in the request and get another access token with a new set of permissions. For example, if we will take the same one that you used before, but instead of Microsoft Teams, we will use Visual Studio, you will get a new set of permissions. And it might not seem much, but you have this one right here, the application read write all. And Microsoft, in its documentation, specifically alarms you and says you should use caution when granting these permissions. It's only 1 out of 3 that it actually warns you about. And the reason is that application read write all. If you actually get this permission, you're basically with a shadow admin in Entra ID environment, allowing you to take control on the entire tenant. This is not just theoretical. what we talked about until this point is something that APTs already use. So what you can see here is that APT 29 used and abused Microsoft device code authentication, just as we saw in less than a month ago. And you know what? This is something that we are very proud in Pantera to already have as part of our production products. What you can see here is that we already have an activated campaign, phishing campaign, detecting the device authentication flow, leading the user, the victims, to click on it and then perform a full account takeover in Azure. Continue from there from all sorts of post-exploitation steps like enumerating all of the users, but it's not only that. We also perform sending emails from within your organization using this exact access token and refresh token. We talked a lot about the attacker's point, but let's look at it from the defender's point of view. So what can you do to stop the bad guys? What can you do? And again, going practical here, is using conditional access in Azure. You will create a new policy, and in this policy, you can set whichever user that you want to include or exclude from this specific policy. Same with the applications, by the way. You can check, let's say that you want to block it for Microsoft Teams, but you want to allow it for Azure CLI. Then you will check specifically the authentication flow of device code flow. At this point, of course, you can choose if you want to block or grant it, but I suggest you to block. And of course, at this point, you can also set if you want the policy to be report only or actually on. If you use the report only, what you will see is that you have a new entry in the sign-in logs showing a successful attempt of using this device authentication flow. If you will block it, of course, it will block it entirely. Meaning that now if the victim will fall into trap, will actually click on the link, would put the user code inside, he will get nothing out of it, but same as the attacker. That's what you will see as the entry log. You will see that it was blocked by a conditional access policy, ending the journey for the attacker at this point. That's a great success from the defenders at this point in time. But you know what? I think it's time to get your hands dirty. And as I said before, I prefer to learn by actually doing stuff, and I think it will help you a great much to try it by yourselves. So what we have here is that we have two new open source tools that we will share shortly, of course, if it will. Let's give it another try for my computer directly. Oops. Okay. So what you can see here is that you can see the web app, but we have it at the CLI version as well. You as the attacker can choose the client ID, can choose the scope. You have something as default, but you can change it, and then request for an access token. At this point, the verification URI will open up, and you will get the user code. You can send it to another user on another device. It will still work. This is just for the demo. You will put the user code inside, and what you will see is the entire victim's perspective. By the end of the login attempt, you will see that on your tool, you will get the entire set of access token and refresh token. Then you can copy the refresh token, go to the second tool, and play with the Focky concept a little bit. So before we took it for Microsoft Teams, we can take this refresh token and use it to get a new access token, but now for another client, for Azure CLI. And as you can see, we can get a new access token for Azure CLI with all of its permissions. By the way, in Azure CLI, part of the scope is to create a new user, and I think that you can understand why it might be very dangerous. So, you know what? I really do believe that the best way to learn is by doing. And I'm trying to connect you, of course, but let's go with it as it is. So the best way to learn is by doing. And I think that if you will use these tools from our Pantera GitHub page, you will learn a lot about it. And you know, I started today with one goal in mind. I told you that I will try and do my best so that by the end of this session, you won't only understand how attackers use this, but you will also be able to perform it by yourselves, hands-on. If you are still here with me, I can only hope that mission accomplished. Thank you very much. And if you have any questions, it will be a good time to ask them. Thank you.
Okay, thank you so much, Nir. And any questions? Questions from anyone? Huh? Yes, sir.
Hello. Good afternoon. Good morning. I just
Yes.
want a quick question. Does that rely on the application permissions of the users that you're authenticating to? Say, for example, if the user doesn't have access to the Microsoft CLI, will you be able to get access tokens from that client ID?
That's a great question. Thank you. That's what I said at the beginning. When you look at scope, the scope of permissions defines the maximum potential that you can actually do. Meaning, if you have one application, let's say Microsoft Teams, it will allow you to send mails inside of your organizations. But because it's the maximum potential, it depends on the user's permission. So that's what the application can do. That's what the client can do. And now the question is what the user can do. So let's say, by the way, it happened to me in one occasion when the organization just used Azure for virtual machines and basically the sort of backend use cases, but they didn't use Exchange or Office 365, whatever to use for the emails. So you won't be actually able to send an email internally. But what you can do is actually try and perform the different aspects of it. And that's exactly the point with what I told you about Foki. You can sort of perform this lateral movement, get a new set of scope, and validate if you have any of these permissions that you can actually act on. That's why this Foki concept is very important. If you hit a dead end, just as you mentioned, I suggest you to try it out. So thank you for the question.
Okay, thank you so much. Interesting question. Anyone else? Oh, we still have some
In the
time.
back,
Any
I
other questions?
see they have a few in the
There you
back.
go.
You showed two screens earlier, right? One from the point of view of the attacker and one from the point of view of the victim. Which activities will be logged in Entra? The activity of the attacker or the activity of the victim?
Yeah, so great question. Thank you again. The activity specifically of the victim. If you will try to log in, that's what you would see. But at the back end, you won't get any notion of it being like getting the user code. Any other questions? Raise your hands.
Anyone else?
Okay.
I'm gonna go around. Wait for me. I'm getting old.
You have a workout today.
Yes, sir.
So is the CA available for P1 or P2? And so basically we should not use application read write all?
Application, okay, so what's important here, again, it's part of the scope concept. If it's part of the scope of the application to perform this operation, it doesn't necessarily mean that the user have this operation in. But what happens, just by the way, on the other side of it, when you don't have, sometimes you don't have any Teams or email like exchange in your organization, but you might be able to phish for the credentials of a developer. Then if the developer doesn't have any mails in his organization, but you can laterally move into the scope of Visual Studio, then you can check it out and see if you can actually use these permissions. That's why I mentioned the concept of the dead end, because as I don't know if you have here like red teamers or hackers that actually practice like attack flow, but you will hit a dead end. And that's why you need to learn how to move laterally and find your other way in. And there's so much opportunities in the different scopes that once you will move around, you will find something for sure that you can continue and propagate the attack. So, yeah. Did I answer your question?
And another, so is it the conditional access, is it P1 or P2?
I think it's P1, but let's check it afterwards. Sorry.
Okay. Maybe a last one, last question for Nir. No? All good? Okay, so
Thank you.
again, let's give it a round of applause for Near
Thank you
Chaco,
very
guys,
much.
from
Thank you.
Pantera. And okay, we'll be going ahead to our next